Hi, this is Somshakar from Mathsguruacademy. If you are watching the video for the first time, please subscribe to my channel and press the bell icon to get the notifications of my latest videos. Today we are going to learn the first chapter of your 10th syllabus, that is real numbers. So before going to that chapter real numbers, we should know some basics, right? So first one is natural numbers. What is natural numbers then? As you all know that all countable numbers are called natural numbers. In simple way we can say that the number starting from 1 we can call it as natural number. Natural number is denoted by n. So next is whole numbers. What is whole numbers? All countable numbers including 0 are called whole numbers. Right? So all countable numbers means the number starting from 1. So along with these numbers there is one more number called 0. So in simple way we can say that the number starting from 0 is called whole numbers. So it is denoted by W. Next, integers. What is integers then? All positive and negative numbers including 0 are called integers, right? So we have positive numbers here and we have the negative numbers here including 0. So these numbers we can call it as integers. All positive and negative numbers including 0 we can call it as integers. So it is denoted by Z. Next, rational numbers. What do you mean by rational number then? The numbers which can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. That means the number which can be written in the form of P by Q, nothing but fraction, right? So these P and Q are integers. What do you mean by integers? The numbers may be positive numbers, negative numbers, or it may be 0. So P and Q can be any integers, but there is one condition that this denominator, that is Q, must not be equal to 0. That numbers we call it as rational numbers. So for example, 2 by 3, it is a rational number. Minus 7 by 4, this is also a rational number. 3 by 6, this is also a rational number. 5 and 10. So these 5 and 10 is also a rational number. How? So these 5 can be written as 5 by 1 and 10 can also be written as 10 by 1, right? So these 5 and 10 also called as rational number. Note, all integers can be expressed as rational numbers. So all these numbers we can express as in the form of P by Q. So these integers can be called it as rational numbers. So next, irrational numbers. What do you mean by irrational numbers? The numbers which cannot be expressed in the form of P by Q, we call it as irrational numbers. The numbers which cannot be written in the form of P by Q, we call it as irrational numbers. For example, root 2, root 3, pi. So to know root 2, root 3 is irrational numbers, you should know some definitions, that is terminating and non-terminating decimals. So let us see one by one. What is terminating decimals? The numbers that has a finite number of digits after decimal point, we call it as terminating decimals. For example, 0.125. So after decimal there are 3 digits, right? So 98.625, after decimal we have 3 digits. 165.04, after decimal we have 2 digits, right? So after decimal point we have finite number of digits, so that's why we call it as terminating decimals. So the numbers that has finite number of digits after decimal point, after decimal we have finite number of digits, that's why we call it as terminating decimals. So these terminating decimals can be written in the form P by Q. So what do we call the numbers which can be expressed in the form of P by Q? Rational numbers, right? So these terminating decimals we can call it as it is a rational numbers. How? See here 0.125 is there. So this can be written as 125 divided by 1000, right? So after decimal we have 3 digits. So we are shifting the digits here. How much digits we are shifting? 3 digits. So denominator, in the denominator we will write 3 zeros. That means 0.125 can be written as 125 by 1000. So it is in the form of P by Q, right? So that's why 0.125 can be called it as rational numbers. So see here, these terminating decimal can be expressed in the form P by Q. So all these terminating decimals we can call it as rational numbers. Next, non-terminating decimals. a number that has infinite digits after decimal point. As the definition says, after decimal point we have infinite number of digits, right? So that's why we call it as non-terminating decimals. So in these non-terminating decimals we have two types. So the first one is non-terminating recurring decimals, and second one non-terminating non-recurring decimal. So let us see one by one now. What is non-terminating recurring decimals? Recurring decimals, the word says recurring means repeating. So repeating decimals, we call it as non-terminating recurring decimals. So non-terminating recurring decimals are the one which has a set of number or decimal to be repeated uniformly. For examples here, after decimal, the number 3 is repeating, right? Next, see here 0.135135. After decimal, 135 is repeating. So there is a pattern, right? 135 repeating. It may be a single number or it may be a pattern, set of numbers. The set of numbers or decimals which are repeating, we can call it as non-terminating recurring decimals. So next, what is non-terminating non-recurring decimals? The one that does not have repeated decimal numbers, we call it as non-terminating non-recurring decimals. That means, so see here, the value of root 2 is 1.41422135. So after decimal, there is no end for the digits, right? But also there is no repetition of the digits, right? Repetition means there is no certain pattern, right? So as it is here, 135 is repeating. So there is a sequence, right? So here there is no sequence. 41422135. There is no repeating sequence, right? So root 3, what is the value of root 3? 1.73205081. And again there is no repeated decimals here, right? There is no certain pattern. So that's why these numbers we call it as non-terminating non-recurring decimals. There is a note, right? Terminating decimals, non-terminating recurring decimals are rational numbers. What do you mean by terminating decimals? After decimal we have finite number of digits. That's one we call it as terminating decimals. And non-terminating recurring means there is a certain pattern of repeating numbers, right? So that one we call it as non-terminating recurring decimals. So these terminating decimals and non-terminating recurring decimals, we can call it as rational numbers. Next, non-terminating non-recurring decimals, we call it as irrational numbers. So non-terminating non-recurring means root 2, root 3, right? After decimal there is no certain pattern of repeating numbers. So that's why we call it as non-terminating non-recurring decimals. So now I think you got the point why we call root 2, root 3 as irrational numbers, right? So next, so coming to our main point, now what is real numbers? All rational and irrational numbers are called real numbers. Rational numbers means it may be integers or it may be fractions, right? So all rational and irrational numbers are called real numbers. So what is prime numbers? The numbers greater than 1 which is divisible by 1 and itself are called prime numbers. That means the number must be greater than 1 and it also divided by 1 and the number itself. So see here, for example, 2, 3, 5. So these are the numbers which are greater than 1 and these numbers can be divisible by 1 and the number itself. For example, 2 is divisible by 1 and it also divisible by 2, right? And 5, it is divisible by 1 and it also divisible by 5, right? 7 is also divisible by 1 and also it is divisible by 7 itself. So that's why these number we call it as prime numbers. So which are those? 2, 3, 5, 7, 11, 13. So what about other numbers? For example, we'll take other numbers, 4. So 4 also divisible by 1 and it also divisible by 4, right? But these 4, it is also divisible by 2, right? So 2 ones are 2 twos are. So this 4 is divisible by 1 as well as 2 as well as 4. So that's why 4 is not a prime number. So take one more example, 6. So 6, this 6 is can also divisible by 1, can also divisible by 2, can also divisible by 3 also, and can also divisible by 6 also, right? So that's why 6 is not a prime number. Getting? So the prime numbers are 2, 3, 5, 7, 11, 13, so on. So there is a note, right? So 1 is not a prime number as it has only one factor. So factors, I think you know the factors. You have done in your 8th standard prime factorization. What are the factors? So for example, 5. So 5 is divisible by 5 only. So the factors of 5 are 5 into 1. Right? So factors of 5 are 5 into 1. The factors of 3, 3 into 1. The factors of 2, 2 into 1. So 1 is not a prime number as it has only one factor. So the factors of 1 is 1 itself, right? So that's why it is not a prime number. Next, composite number. What do you mean by composite number? The number greater than 1 and not a prime number is called composite numbers. That means the numbers which are not a prime numbers, we can call it as composite numbers. That is, in a simple words, the numbers which are not a prime numbers, we can call it as composite number, but except 1. So there is a note here, right? 1 is not a prime number and not a composite number. So 1 is not a prime number and at the same time it is not a composite number. So example for composite number 4, 6, 8, 9. Fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? That is, the statement says every composite number can be expressed as a product of primes and this factorization is unique apart from the order in which the prime factor occurs. So I'll repeat once again. Every composite number can be expressed as a product of primes. You know the composite number, right? What do you mean by composite numbers? The numbers which are not a prime numbers, we can call it as composite numbers. For example, 24, this is a composite number, and one more 36, this is also composite number. So what the statement says here, every composite number can be expressed as a product of primes. So 24 and 36 are composite numbers. This can be expressed as a product of primes. How? So we'll do the prime factorization here. 24. So 24 is divisible by 2. So next it is divisible by 2 only. 2 6 are 12. So next 2 3s are 6. 3 1s are. So 24 can be written as 2 into 2 into 2 into 3. Right? So the factors of 24 are 2 into 2 into 2 into 3. Next 36. So we'll do the prime factorization for 36. So 36 can be divisible by 2. So 2 18s are 36, 2 9s are 18, 3 3s are 9, 3 1s are 3. So 36 can be written as 2 into 2 into 3 into 3. So 2 into 2 into 3 into 3. So now see here, every composite number. So 24 is also composite number, 36 is also composite number. These composite numbers can be expressed as a product of primes. What do you mean by product? That means we have to multiply the numbers. So product of primes, every composite numbers can be expressed as product of primes, right? So see the statement, every composite number can be expressed as a product of primes and this factorization is unique apart from the order. So 24 can be written as 2 into 2 into 3. 36 can be written as 2 into 2 into 3 into 3. Right. So these composite numbers, we have expressed these composite numbers as a product of primes. Next, the factorization is unique apart from the order. So here the order doesn't matter. So then what do you mean by factorization unique? Unique means different. So there is no two composite numbers having the same factors. So next, HCF and LCM. How to find the HCF and LCM for two numbers? For example, so we have to find the HCF and LCM for 24 and 36. As you all know, HCF means highest common factor, LCM means least common multiple. So HCF of 24, 36. So as the name says, HCF means highest common factor. So the factors which are common in both the numbers, we have to write it. So 2 and 2 is common. Again 2 and 2 is common, right? So I'll write 2 into 2 into, so again 3 and 3 is common, right? So into 3. So what it will become? 2 into 2, 4, 4 into 3, 12. So HCF of these two numbers is 12. So then LCM of 24, 36. So LCM means least common multiples. That means the maximum number of factors, repeated, that one we have to write it. So here see, in 24 there are 3 times 2 is repeated, but in 36 2 times the 2 is repeated, right? So the maximum number of 2 is here. So we have to take this one, 2 into 2 into 2. So 2 into 2 into 2 into, so 3 here. For 24 there is only 1 3. For 36 there are 2 times. So we have to consider this one, 3 into 3. So LCM is 2 into 2, 4, 4 2s are 8, 8 3s are 24, 24 3s are 72. So this is the LCM. So this is how we can find out the HCF of LCM of any two numbers or any three numbers. So then we have the relation. So what is the relation? LCM into HCF is equal to product of two numbers. So this is a one relation, or we can call it as a formula. LCM into HCF is equal to product of two numbers. So for example, we will take this one as example, 24 and 36. So for these two numbers we got HCF is 12 and LCM is 72, right? So we'll substitute here. The LCM is 72 into HCF is 12 is equal to product of two numbers, means the two numbers which we have taken, we have to write it. So product means multiplication of two numbers. So 24 into 36. So what we will get? 72 into 12 will get 864, and 24 into 36 will get 864. So LHS is equal to RHS. So this is a one relation. What is that? LCM into HCF is equal to product of two numbers.